Hello everyone and welcome to another part of the Galaga SDL tutorial videos, and I'm pretty excited about this video since we're going to finally have our collision detection working. It's not going to be finalized in this video, we're just going to use our broad face colliders, but we're going to actually have objects colliding with each other. So the first thing that we need to do is go to our physics entity class, and we need to do a few changes in here. The first one will be right here in the protected section. We need to assign it a unique ID. So we're going to add in an unsigned long, which will be called MID. And we also need a way to get this ID back. So we'll go down here in the public function section, and we will add an unsigned long function called getID. There we go. Now we need to implement this function, so let's go ahead and do that. So we'll have it right underneath the constructor, and this one will just return our MID, and that's it. So now that we have this set up, we can start by creating our PhysicsManager. The PhysicsManager, what it will do is pretty much contain pointers to all the physics entities that were registered to it, assign them a collision layer, and then do the collision detection based on whichever layer the entity is on. So this will be a lot more clear once we start creating our PhysicsManager. Let's do that then. We can add a new item in our physics filter and call this one PhysicsManager.h, and then if not defined, underscore PhysicsManager_h, define underscore PhysicsManager_h. This manager will be a singleton, just like all our other managers. So what we'll do is include phys entity, because it needs references to all our physics entities that we register to it. And we'll also include bit set. And we'll use that as a bit field so that we know what each layer should collide with whichever other layer. Now for our class, we will start by calling it PhysicsManager. And we will need a couple of enums for this class. So in the public section, we will have an enum class called collision layers. And we will also have another enum class called collision flags. There we go. Okay, so the collision layers, we will have a layer for each type of collision that we want to take place. For example, we will have a friendly layer, so that's where the player will be, and this layer needs to collide with the enemies and the enemy bullets. So we have this one. We will also have a friendly projectile layer, and the friendly projectiles don't need to collide with the friendlies, but they also don't need to collide with the hostile or the enemy projectiles. So that's why we have a layer just for them. We will also have a hostile, so that's where all the enemies will be, and a hostile projectile layer. Hostile projectile layer. Our friendly one will start off being 0. And we will also add one more here, which will be called max layers. So max layers, so that we can use this one if we want to iterate through all the layers. And that will be it for this enum class. Moving on to the next one. This one will be a collision flag. So we need this one to actually be powers of 2, their values. So first we'll have none, which will be equal to 0x00. We will have friendly, which will be equal to 0x01. Should probably have the comments here. There we go. Friendly projectile, Maybe I should call it projectiles, not just tile. There we go. And then, so friendly projectiles is going to be equal to 0x02. Hostile is going to be equal to 0x04. And finally, hostile projectiles is going to be equal to 0x08. And that will be it for our enums. Now, to move on to our private variables, since this one is a singleton class, we need an instance variable. So private static PhysicsManager pointer is instance. And we will also have two more variables that are a bit complex. So the first one will be an std vector of physics entities. So physics entity pointers. And this one will be called mCollisionLayers. But it will also be an array. And the size of the array will be a static underscore cast of unsigned int. And that will be a cast of the collision layers max layers. Okay, so the idea here is that each layer will have its own array or its own vector. And this vector will have all the entities that belong to that layer. So the size of the layers is how many collision layers we have. So that's going to be 4. And each one of these 4 will have its vector that contains all the entities that belong to that layer. Now, to move on to our layer masks, we can do an std bit set. And the size of that bit set will be a static underscore cast of unsigned int of collision layers max layers. So that's going to be 4. And we'll call this one m layer masks. This also will be an array, so we'll do the exact same thing. So static underscore cast of unsigned int of collision layers max layers. And that will be it for these two variables. The use of these two will become more clear as we implement the functions that we need to use them for. So let's move on to our next variable. And this one is just an unsigned long called mLastID. We will use this one along with the MID in the physics entity to assign a unique ID to each physics entity that we register with the manager. Now, for our public functions, we will have a static PhysicsManager pointer called instance. So just the usual singleton paradigm here. We will also have a static void release and a void set layer collision mask. This one will take a collision layer because we need to tell it which layer we want to set the mask for. So we'll call this one layer. It will also take a collision flags called flags. And that will contain the layer mask for that layer. Next up, we will have an unsigned long called Register Entity. And that will take in a phys entity pointer, which is the entity we want to register, and a collision layer, which will be the layer that entity should be registered to. And then next up, void unregister entity, and that will take an unsigned long ID. And that's what this ID will be used for. So we register the entity, we give it an ID from the PhysicsManager. When we want to unregister it, we pass an ID again so the PhysicsManager knows which entity it is and removes it from the layer vectors. Then next up is just void update, and that will be it for our public functions. Our private functions will be our constructor and destructor, and that's it. So private PhysicsManager and destructor of PhysicsManager. And that will be it for this class, but we do need to override a few operators. So the bitwise AND and the bitwise OR operators, we need to override them so we can actually do bitwise operations on these collision flags. So over here, after the class is finished, we can add in an inline function of type PhysicsManager PhysicsManager collision flags, and then operator bitwise AND. This one will take in a PhysicsManager collision flags A and a PhysicsManager collision flags B. What it will do is just cast A and B into ints, do a bitwise OR operation on them, and then cast them back into a collision flag. So we will return a static cast of PhysicsManager collision flags of a static underscore cast of unsigned int of A bitwise ORed with a static cast to unsigned int of B. And that will be it for the operator overloading for the bitwise OR. Now we can do the exact same thing for the bitwise AND, so we just need to replace the OR with an AND here and there. And that will be it for this class. Now to move on to our .cpp, we need to go in here in our source files and create it. So new CPP file called PhysicsManager. And in here we will include our PhysicsManager.h. Then the first thing that we need to do is to initialize our S instance. So for this one, our PhysicsManager pointer, PhysicsManager S instance is going to start off being a null pointer. Then next up is our instance function. So for our instance function, we can say if S instance is a null pointer, we need to initialize it. So S instance is going to be equal to a new PhysicsManager. And then we will return S instance. Then for release, we will say that we want to delete S instance, and then S instance is going to go back to being a null pointer. And that will be it for our static functions. Now to move on to our set collision mask, this one is a bit more complicated. So what we want to do is take in these flags and then set them into the bit set that we have here, so the layer masks. So what we'll do is say that m layer masks at our layer that we have here. So we need to cast this one into an unsigned int. So static underscore cast unsigned int of layer is going to be equal to an std bit set of static cast unsigned int of collision layer max layers. So what we're saying is pretty much we want a bit set, and the size of the bit set will be our max layers, which will be 4, but we're just casting it into an unsigned int. And the value of that bit set will be a cast of our flags that we're passing in. So it's going to be a static underscore cast of unsigned int of our flags that we are passing in. And that will be it for that function. I hope that one is very clear. So pretty much each layer has its own mask, and that mask, so for example the layer that we passed in, if we pass in the friendly layer, we convert that, we cast it into an unsigned int. So the friendly, when it's cast, it will be 0. So m layer masks at 0 will be equal to a new bit set of size 4, and the value will be whatever we pass in into the flags. Now to move on to registering an entity, that one will be an unsigned long PhysicsManager register entity. And what we want to do is find the index of the layer that we're passing in. And to do that, we're going to do the exact same thing that we did here. So we'll do mCollisionLayers at static cast to unsigned int of the layer dot pushback our entity. So we're just adding the entity to the right collision layer. Then we're going to increment the last ID. So last ID plus plus, and then we're going to return the last ID. And that will be it for registering our entity. You'll notice that we're incrementing first before we're returning it. So that means that we will never have an entity with an ID of 0. And that's going to be helpful later on, because if an ID has a phys entity has an ID of 0, it means that it wasn't registered, so we don't need to actually remove it. Now, moving on, we can do our unregistered entity. So void PhysicsManager unregistered entity. This one will take in an unsigned log called ID. There we go. And then we will do a Boolean found. It's going to start off being false. So we'll pretty much just take an ID, look into all our collision layers, look for that one entity, and remove it from that collision layer. So for int I equals 0, I is less than static cast of unsigned int of collision layers max layers, and found as long as it's not found. That way we can just, whenever we find the entity that we're looking for, we remove it, set found to true, and then we just exit the loops. And then I++. We will also need a j, because we need to iterate through the vector of that layer. So for int j equals 0, j is less than m collision layers at I dot size. So dot size, and not found, just like the other one. Then we can do j++. So in here we can say if m collision layers at I j get ID is equal to the ID that we're looking for, then we just found the entity that we're looking for. We can say m collision layers at I dot erase m collision layers at I dot begin plus, and then we're going to add our j value. So plus j. And that will be it for this one. We also need to say that found is equal to true. So we're gonna loop through all the layers, and then look through all the vectors in these layers, find our ID that we're looking for. Once we find it, we erase it from the collision layer and say that found is true, so we can exit these two loops and move on. So that will be it for our unregistered entity. Then now we can move on to our constructor. So for the constructor, we can say that, there we go. So for our constructor, we can say that our m last ID is going to start off being 0. And for int I equals 0, I is less than static cast to unsigned n. Maybe we should make I unsigned as well. So unsigned int I equals 0, I is less than static cast of the unsigned int of collision layers max layers, then I++. And what we're doing here is pretty much initializing our masks. So the masks at first are going to start being set as null, none, so that no layers interact with each other unless we specify otherwise. So over here, what we'll do is say mLayer masks at I is going to be equal to what we can do is get the bit set from here. So we're pretty much going to copy what we have here, but instead of this one, we can just say we want to have it as collision flags none. And that will be the initial value of all our layer masks. Now that we have our constructor done, we can move on to our destructor. So PhysicsManager destructor for unsigned int I equals 0, I is less than static cast of unsigned int collision layers max layers I++. And what we're doing here now is we're just clearing the collision layers. So we can say mCollision layers at I dot clear. And that will be it for our destructor. Now for our update, and this is where we're going to handle all our collision detection. So we can say void PhysicsManager update for int I or unsigned int I equals 0, I is less than static cast of, well, static cast to unsigned int of our collision layers max layers, and then I++. We will do the exact same thing, but with j again, because each layer needs to interact with another layer. So that's what we're going to do. So for unsigned int I equals 0, or j, so unsigned int j equals 0, j is less than static cast of unsigned int of our collision layers max layers, and then j++. Okay, now that we're iterating through all our layers twice, so pretty much comparing each layer to each other layer, we need to make sure that the mask is set for these two layers to be colliding with each other. So what we'll do is say that if mLayer masks at I dot test j. So what we're saying is that as long as the layer mask for I, so for example, it will be a lot easier to kind of explain it here. We have 4 layers, so the 4 layers will be in our bit field, because our bit field is 1, 2, 4, and 8. So this one is the friendly layer, this one is the friendly projectile layer, this one is the hostile layer, and this one is the hostile projectile layer. So we're saying that if, let's say we are at the friendly layer, and we need to know if it should collide with the hostile layer. So our bit field for the friendly layer needs to be able to collide with the hostile and our hostile projectile. So the bit field for the friendly layer will be 0, 0, 1, 1. So for our friendly layer, we need to test if this is a 1 or not. So our layer mask at I, which is the friendly, test j, which is the hostile in this case, if it's 1 or not. If it is 1, then we need to collide. And then we also want to say that and I is less than or equal to j. That way we don't check the same collisions twice. We don't go through the hostile and check it against the friendly after we did a friendly against the hostile, so that we don't trigger our collisions twice. So that's what this section is for. Okay, so now that we know that these two layers should collide, we need to go through their two vectors and check the collisions against each other. So we'll say that for unsigned int k equals 0, k is less than m collision layers at I dot size. So dot size k plus plus. And then we need to test this vector, so collision layers at I, with collision layers at j. So we need to loop through another vector. So for int unsigned int L equals 0, L is less than m collision layers at j, this time, dot size, and then L plus plus. Okay, so we need to check now if two of these layers collide together with each other or not. So for that, we need to start implementing our collision detection. So first we can say that if m collision layers at I k, because keep in mind that collision layers at I is this one and k is what we're looping through, so that's why it's ik. And then we need to check its collision against the entity at collisions j l. So we need to implement a function called checkCollision and pass it in our m collision layers at j l. So that's what we're going to be working on next. We need to implement this function in our PhysicsEntity class. So let's go back to our PhysicsEntity. And in here, in the public section, we will declare a function called Boolean check collision. And that will take a PhysicsEntity pointer called, this one will take a PhysicsEntity pointer called other. So other, there we go. Now let's implement this one. And right here, so right underneath get ID, we'll have it there and say that we want to return the collision between the two. So how do we check collision between two entities? The first thing that we need to do is create a physics helper .h so that we can do the collision checks in there, just like we did with our math helper. So we can go to our Solution Explorer. In our physics header files, we can add a new item, and this one will be a .h, and let's call this one physics helper. And in this one, what we're going to do is, well, let's see where it is, physics helper. So if not defined, underscore physics helper underscore h, define underscore physics helper underscore h. Then next up, we will include our circle collider.h. We will include our box collider.h. And we will also include our math helper.h. So now that we have everything that we need included, we can start off with doing our collision check. So we can do inline collider check, which will take in a collider pointer called C1 and another collider pointer called C2. And the idea here is that we can just pass in an inline bool. The idea here is that we can pass in two colliders, and this function would decide what kind of colliders they are, and we call the corresponding function we need to do a collision check between these two colliders. For example, we can say that if C1 get type is equal to a collider type circle, and C2 get type is equal to a collider type circle. So if both our colliders are circles, what we want to do is to do a circle-circle collision. So over here, we can declare a new function. So we'll say that we want to do return circle-circle collision of static cast to a circle collider pointer of C1 and a static cast of circle collider pointer of C2. There we go. So now let's implement our circle-circle collision. So we'll do it right here. Inline Boolean circle-circle collision. This one will take a circle collider pointer called C1 and a circle collider pointer called C2. And how do we do a circle-circle collision? We just need to know where the two circles are in the world, and if the distance between them is less than the sum of their two radii, then they collided. So that's what we're going to do. Say return C1 position minus C2 position dot magnitude. So we're getting the magnitude of the difference between the two, and that's the distance between them. As long as less than C2 or C1 radius or get radius plus C2 get radius. Okay, so if the distance between the two circles is less than the sum of their two radii, then there is a collision that happened between them. But we still don't have a getRadius function for our circle collider, so that's what we need to implement next. We'll go to our circle collider. Okay, let's go to our circle collider.h, and in our public function right here, maybe somewhere underneath the get for this point, we can say float get radius, and we will implement that to just return m radius. So just float circle collider get radius return m radius, and that will be it for our circle-circle collision. We'll just do the circle-circle collision for this video because doing all types of collisions will take way too long. Maybe we'll do it in the next video. But for now, we'll just do the circle collisions, and we're gonna just use the broad face collision for that. Okay, now that we have all this set up, and we have our physics entity now .cpp doing the collision check, we can go back to our physics entity.cpp and our collision check function and add the new functions that we just made. So instead of circle collider.h including, we can do physics helper.h instead. And then we can go back down to check collision. And in here, what we need to do is to say that we want to return a collider check. So collider check of our broad face collider. So our m broad face collider against the other m broad face collider. And that will be it for this function. Now we should be able to tell if we got if the two broad face colliders intersect or not, and we can use that in our PhysicsManager. So if there is a collision between this entity right here and that entity right here, we can do something about it. And what we want to do is tell the two entities that they just got hit. So in our physics entity.h, we need to add a function called hit. So let's go back to our PhysicsEntity.h, and right underneath check collision, we can do a virtual void hit, and this one will take a physentity pointer called other, and that will be the other entity that just got hit, or that just collided with our entity. So let's implement that. That will be just underneath check collision. We don't really need to have anything in it for the base class, but we need to do other things with it for our other classes, for example, the player. So now that we have our hit, we can go back to our PhysicsManager and say that our M collision layers at I and K just got hit by M collision layers at J and L, and our collision layers at J and L got hit by, that is not the one I'm looking for, so got hit by our M collision layers at I and K. And that will be it for this part. So now that we have our collision detection sort of working, we need to initialize our PhysicsManager, and we need to pass in the layer masks so the PhysicsManager knows which layers should be colliding with which layers. And for that, we will go to our game manager. So let's go to our managers and game manager.h. In here, right underneath screen manager, we can say include our PhysicsManager. We will also add it in here. So we will say that underneath our audio manager, we can do PhysicsManager pointer mphysmgr. Then in our .cpp file, we can initialize it just like we initialize the rest of the managers that we have. We probably want to initialize it before the screen manager, so that's what we're going to do, is say mphysmanager is going to be equal to PhysicsManager instance. And in our destructor, we will probably release it right after the screen manager as well. So mphysmanager or PhysicsManager release, and mphysmanager is going to be equal to a null pointer. And that will be it for initializing it, but we still want to set the collision masks. And for that, we will go through our each one of our layers. For example, right here underneath the initialization, we can say mphysmanager set layer mask of physics collision layers friendly. So we're setting the mask for our friendly layer, and this mask will be the hostile or the hostile projectiles. And that's pretty much the way we're going to set our layer masks. So the friendly layer should collide with the hostile layer, and not the friendly projectiles. We want the hostile projectiles. There we go. Now that we have this, we can duplicate it and say that our friendly projectiles we will only want them to collide with the hostiles. We don't want the two projectiles to hit each other. And then next up, our hostile layer, we want it to collide with the friendly layer along with the friendly projectiles. And finally, the hostile projectiles will be colliding with the friendlies only. So now that we set all our layer collisions, we should be able now to see collisions happening. So let's go back to our player maybe, and then implement our hit function in the player. So let's go to our player.h. Let's see, where were they? In Galaga, player.h. And in here, what we want to do is to add the hit function that we added before. So over here we have in our physentity.h, we have a virtual function called hit. We want to override it in the player because the player needs to do specific things when they get hit. For example, do the death animation. So we will go down to the public section in the player class, and right underneath is visible, well, probably in between is visible and is animating, we will add void hit physentity other, and this one will be an override. But we will also add a function called was hit. So Boolean was hit. So we will need these two functions right here. Oh, we already had one from before. So let's just cut this one and paste it right here so that they're both together. Now let's go to our hit function that we just created. So over here. And for our hit function, we're gonna pretty much take everything that was in was hit. So let's cut was hit and put it right underneath hit. So everything we were doing in hit, we will put it in was hit. And we will also add a new variable called was hit. So in player.h, we will go to our protected section or private section, and right underneath animating, we'll do Boolean m was hit. We probably need to initialize that, so we will go to our player, and then underneath animating here, was hit is going to start out being false. And then we'll go down to our player hit and say that was hit is now true. So m was hit is equal to true. And the place where we set it to false is going to be down here in the update. So as long as we're animating, if m was hit is going to be equal to false. And the reason why we did this is because, so we get hit, then we let the level know that we got hit, and then the next frame was hit is going to be back to false, so that we don't keep doing the wait animation every frame in the level. You'll see where that takes effect in a second. So let's go back to our was hit function and just return m was hit. That probably needs to be a Boolean, so we need to change was hit back to being a Boolean. So let's go back to player.h, and was hit can be a bool. Okay, so now that we did all these changes, what we can do is go to our level and see what we can change over there. But we also need to register the player to our physics manager. So instead of including the box collider, we can just add, actually, we can just include PhysicsManager.h along with this, and then we need to register the player to the physics manager. So we can say MID is going to be equal to physics manager instance register entity, and the entity we want to register is this, which is the player, and the layer we want to register him to is going to be the friendly layer. And that will be it for registering an entity into the physics manager. So what about removing an entity from the physics manager? For that, we will go to our PhysicsEntity.cpp, and we will go to our constructor and destructor. So for the constructor first, we need to initialize all the IDs to 0 by default. And then in the destructor, we can say over here, if the ID is not equal to 0, that means that we're registered with the physics manager. So as long as our ID is not 0, we want to unregister that entity. So physics manager instance unregister entity MID. And that will be it for this one. We probably need to include physics manager in here as well. There we go. So, all right, now that we have everything set up here, what we can do is go to our level.cpp. So solution Galaga level.cpp. and the level is a huge class. And we go to down where we are killing the player. So I think that was in handle collisions. Where was that? Handle collisions, there it is. So if the player was not hit, we will do some changes in here. So if the player was not hit, that's fine. But instead of pressing X to kill the player, we can say if mPlayer was hit. So if the player was hit, we don't need this one anymore. We can do what we're doing in here. So now that we have this right there, we can check and see if the game actually runs. Okay, looks like compiled. And let's see if the player actually gets hit. So right now we are saying that the friendly layer collides with the hostile layer and the hostile projectile layer. So we should be able to collide with the enemies when they start diving at us. So let's wait for all the enemies to spawn and go into formation, and then once they start diving, we should be able to collide with them in theory. There we go. Yep, it looks like we did not. So let's see why that didn't happen. Right, because we're not actually updating the PhysicsManager. So the PhysicsManager, its update will be in the late update, where we have this comment right here. So any collision detection should happen here. So we can say PhysicsManager update right here. And let's run again and see how it goes. So that was in the game manager.cpp in late update. Yes, late update. There we go. Now we just need to wait for them to all go into formation once again. And maybe we can add a breakpoint. So PhysicsManager right here, so that we can see as soon as we enter a collision, we can see what just happened. Okay, so it's not registering still. Let's see what is going on here. Our layer masks, so we have 4 masks. Each mask is, the masks seem to be set correctly. Our collision layers, right, so we have the player in here in the friendly layer, but we don't have the enemies registered yet, and that's why no collisions are being registered. So we will go to our enemy.cpp. So in enemy.cpp, we need to register the enemies just like we did with the player. So in the enemy constructor, we can say MID is going to be equal to, and we probably need to include the PhysicsManager in here as well. So include PhysicsManager.h. So over here, we can say MID is going to be equal to PhysicsManager instance register entity, and our entity will be this, and the collision layer will be hostile. There we go. So now we're registering our entities, and if we go to the collision layers, it hasn't been set yet, so let's wait for it. And we'll just remove the breakpoint so that we can just check whenever a hit occurs. There we go. Okay, so now once they start diving, let's see if that happens, and there we go. We just caught a collision hit. And as you can see, the player died multiple times at once. That's the main reason for that, is because we're not ignoring collisions when the player is in the dead state. So we need to implement a way to actually ignore collisions whenever we want to. And to do this, we will need to add a new function. So in our PhysicsEntity.h, as a protected function, what we're going to do is add that function called ignore collisions. So just 1 second here. In here, we can add a virtual Boolean called ignore collisions. And then we can just implement this one. And in the physics entity, by default, we're just going to return false. So we can say that any physics entity that tries to ignore collisions by default returns false. But in some cases, we want to actually ignore collisions. So we need to override this function in the other classes where we want to actually the collision not to be ignored. Or we actually want the collision to be ignored. So for the player, over here, we can go to player.h, and in the private section, we can do Boolean, ignore collisions, override, and then implement this one right here. So right after the destructor, we can say that the player should be ignoring collisions only if the player is not visible. So return not invisible. So as long as the player is not visible, we want to ignore his collisions, or the player is animating, which means that the player is in his death animation right now. So now that we have these two here, we can do the same for the enemies. So for example, in enemy.h now, so if we go to enemy.h, we can go to our protected section, and in here, we need to add the same function that we added in the other one. So all the way at the end, after the render states, we can say Boolean, ignore collisions, override, and then implement this one. And for the enemies, on the other hand, we only want to do collision check as long as the enemy is in one of these states. So flying state, formation state, or dive state. If the enemy is dead, we don't want any collision detection. So we can say return m current state is equal to dead. So if m current state is dead, ignore collisions. And that's what we're going to do for that. Once we go now back to our PhysicsEntity.cpp, in our check collision function, we can say that if ignore collisions or other ignore collisions, return false. So if either one of the two entities wants to ignore this collision, just return false and say no collision happened. So now let's run it and see what happens. There we go. Okay. We'll probably need to add the bullets onto the friendly projectile layer as well. So that's why the bullets are not colliding right now, but we'll do that in a second. First, we need to check if the player actually dies and stays dead. It doesn't collide more than once. There we go. Only died once. Ready, and then back, and then died again. So no multiple collisions are happening, but it seems to be working pretty well. Now we need to handle the bullets. So for the bullets, if we go to our bullets.h, in the constructor, we need to add a Boolean friendly. So if the bullet is passed in as friendly, we will add it onto the friendly projectile layer. If it's passed in as not friendly, we'll add it to the hostile projectile layer. So we'll go to our bullet.cpp. We will add this to the constructor. And over here, we can say that if friendly, or we probably don't even need the brackets for that. We will also need to include the PhysicsManager.h. So if friendly, PhysicsManager instance, register entity, this into the friendly projectile layer. Else, we want to do the same thing, but we want to register it to the hostile projectile layers. There we go. And then we will probably have an error now because wherever we are creating the bullets, it's going to complain that we didn't assign it. So that's in the player, and the player should have a friendly projectile. So we'll say that it is true for the friendly projectiles. Now let's run it, and now the bullets should be able to collide with the enemies. But nothing really happens right now, right? We're not doing anything with the collision for the bullets. We want the bullets to disappear when they collide with an enemy. So let's add that first because it's not going to do anything right now. So let's add our hit function for the bullets as well, just like we did with the enemies and the player. So void hit physics entity other override, and then implement this function. And as you can see here, when we're off screen, what we're doing is that we're reloading the bullet. So we can pretty much do the exact same thing for this one. So we can say that if we were hit, we want to reload. But we also reload. But also we only want to do this if we are active. But we are only going to get hit if we're active if we decide to ignore collisions as long as we're not active. So we'll do this right here, is say that we will also override ignore collisions. So we can add a private section and say void ignore collisions in here, and that one will be override. Right, ignore collisions is Boolean. So Boolean, ignore collisions, and then we can create this one. I probably don't like it here. We can have it right underneath hit. So for ignore collisions, we're going to return not active. So as long as we're not active, we want to ignore collisions. Otherwise, don't ignore any of the collisions. So that will be it for the bullets. So let's run it and see how that goes. There we go. So let's try to, and there we go. So the bullets are now colliding with the enemies whenever they get hit, and they disappear. So that seems to be working pretty well. I think what we're going to do in the next video is add the enemy death. So we already have the enemy collision working. We just need to send them to their death state and run the death animation. We already have the player dying, so that seems to be working out pretty well. We just want to have it so that probably want to wait until all the enemies are back in formation before the player is respawned, but we'll add that later on as well. But I think for the next video, what we're gonna do is to add the enemy's death state and death animation. But this is gonna be it for this video. It's pretty much an hour long, so hopefully it's not too long. If it is, please let me know. But I really hope it helped. If you have any questions, suggestions, or feedback, please leave them below. Otherwise, thank you very much for watching, and I will see you in the next video.